Next is Christopher's road trip. Christopher borrowed his mother's car to run a quick errand. We're going to use this graph and we're going to describe what Christopher does as he borrows the car, goes away on his errands, and comes back. And we're going to describe his motion based on the information that we have. We're going to answer these questions. You should answer these questions in your packet. I'm going to go to my particular graph so that I can talk about what's happening in each segment. Here's the graph. Let's start answering question number 1. Question number 1 is asking a question. Here's the question. How far did Christopher's car travel between points A and B? Here's point A that starts at 0 meters. Here's point B. Now we just need to notice where is point B on our graph. It looks to me that Christopher traveled 150 meters from point A to point B. Question number 2. How much time did it take for Christopher to travel from point A to point B? Let's look again at our graph. This is point A right here. Point B comes in right around here. We're talking about time. So from 0 to 10 is 10 seconds, and about midway through here is about 15 seconds. It took Christopher about 15 seconds to travel that distance. Let's move on to question 3. Describe the motion of Christopher's car between points B and C. So, we're looking here between points B and C. Remember, this is a position versus time graph. So, what position is Christopher in? He's at the 150 meter mark. Does he change that position? Does it go up or down? Let's look. No. It doesn't seem like it's going up to 200. It doesn't look like it's going down to 100. So in this particular instance, he's staying at 150. So if you're in a car and you travel forward to a stoplight and stop, you are no longer going forward any amount of distance. We call that to make a stop. That is what Christopher is doing in this particular case between points B and C. Christopher is stopping. Let us move on. What is the speed of the car between points A and B? Speed. This is an interesting question. Here is the part of the graph we're looking at. Speed, or velocity, is equal to our distance divided by our time. We recall in our first problem, we noticed that Christopher traveled 150 meters, which was a distance. And it took him 15 seconds, which was a time. If we take that 150 and we divide that by 15, we should get something like 10 meters per second. Our distance was in meters, and my time was in seconds. Christopher was traveling 10 meters per second between points A and B. How would I describe the slope of the graph between points D and E? Let's look. So, this part of the graph here, what's happening? It looks like it's sloping downward. But this is a position versus time graph, which means Christopher went up to 150 meters, and then it looks like he's going down to 100, then down to 50, and stop. What does that mean if you walk forward to 150 meters and then you go backwards 150 meters? That is what we call negative. So Christopher looks like he was going backwards. Either he was going backwards or he was going in a negative direction. The slope of the line here tells us It's sloping in the downward. The downward position is negative. That tells us that he's going to be either going a negative direction, which could be any of these possibilities. North is positive. East is positive. South is negative. And west is negative. So, negative directions could possibly be, he could be moving south, or he could be moving west. Last questions on Christopher's trip. Is Christopher traveling faster between points A and B or G and F? You recall that between points A and B, he was traveling at 10 meters per second. Now we're asking about this section of the graph. Let's figure it out. Velocity is equal to distance divided by time. What is our distance? Our distance looks like he's at 50 meters. How much time did it take him to do it? It looks like he's starting at 75 seconds and he goes to 95 seconds. 75, 85, 95. How much is that? Let's see, 75, that looks like it's about 20 seconds. When I divide 50 by 20, I get 2 meters per second. So, here's the difference. This negative slope here says that Christopher is traveling in a negative direction. He was traveling faster from A to B than he was from F to G. This negative denotes that it was in a negative direction. It looks to me that Christopher also ended up right here. It looks to me that Christopher also ended up right here, back at 0. If Christopher went all the way up to 150 meters, then back down backwards to 0 meters, guess where he's at? When he gets back here, he is back home. So he either stops or he's back at home. I hope you enjoyed this video.